Yeah, hello friends. Now we are going to discuss about addressing modes of 8086. And addressing mode, what do you mean by addressing mode? Addressing mode gives you how the data or operands are located, how the data and operands can be accessed by the CPU through the instruction. And in a particular instruction, that instruction may belongs to one or more addressing modes, and sometimes that instruction may not belongs to any addressing mode also. And in 8086, the addressing modes can be classified into two ways. One is sequential control flow, other one is control transfer. In sequential control flow, upon executing an instruction, it goes to the next instruction, which is immediate to that instruction. Just after one instruction, go to the immediate instruction. And whereas in control flow, instead of going to the next immediate instruction, it goes somewhere, maybe within the segment, or it may be in other segment even. So by using an instruction like call, return, jump, so you can have all these. So in this way, we have sequential control transfer and sequential control flow and control transfer. So in sequential control flow, there are about eight, whereas in control transfer, there are about four. So totally we are having 12 addressing modes for 8086. Let me see sequential control flow instructions. The first and foremost thing is immediate addressing mode. In immediate addressing mode, the data is available in immediate manner. If you observe an example, move x comma 0005h. This 0005h is an immediate data that can move directly to the AX. Of course, based on our requirement, we can move either 8-bit operand or we can move even 16-bit operand. This is an example for 16-bit operand. Yeah, this is the immediate. Now coming to direct addressing mode. In direct addressing mode, the operand will be accessed directly. If you observe an example here, move x comma within brackets 5000 h. The meaning of this one is at an address 5000 h, you are going to have the operand. That operand to be moved to the AX. So you are going to have an address in the instruction, go to that address, get the operand and move to the AX. This is direct. Now coming to the register addressing mode. In register addressing mode, the data or the operand is available in the registers. When I say move BX comma AX, the data is available in the AX and we move to the BX. Data available in the AX and move to the BX. This is very straightforward addressing mode. Now coming to register indirect addressing mode. So this is advanced to the register addressing mode. Instead of move x comma bx, we are observing here move x within bracket bx. Means bx contains some offset address. Based on that offset address, you are going to have a effective address. From that effective address, the data can be moved to the AX. Instead of bx, we can also use si or di as offset address. And for these kind of addressing modes like sequential control flow, the default segment is going to be the data segment or the extra segment. So based on data segment, extra segment, you are going to get segment address, and based on bx, si or di, you are going to have offset. After getting base and set, you are going to get effective address, and effective address get have the value, and that value move to the AX. This is register indirect. And now coming to the indexed addressing mode, this is a special case of the register indirect. Instead of general register BX, you are going to use of a special register calling it as SI. SI nothing but the source index. So if you use index registered in the place of general purpose register, register indirect mode becomes the indirect addressing mode. So based on the context, you can also use of for DI, SI for source related operands, DA for destination related operands. Now coming to the register relative addressing mode. So This is the combination of mm, relative and register indexing mode. So if you observe an instruction, move ax comma 50h within bracket bx without 50h, this is going to be the register indirect or register indexed also. For that, you are adding 50h. So where 50h is going to be calling it as a displacement. That's why we are calling here it as a relative. We are calling relative because we are adding 50h. Means bx contains the offset address. Bx contains the offset address that is added with the 50. That is added with the 50. So this is going to becomes the final offset address. For this final offset address, the segment address available in DS and ES. So upon calculating the segment address with the offset address of 50 plus BX offset address, you are going to get an effective address. From that effective address, you are going to get a data. That data will move to the AX. So because of adding of 50H here, so you call this as a relative mode. Now we'll see based indexed addressing mode. This is the combination of based mode and indexed mode. So without this SI part, this is looking like a register indirect with the address of the data available in BX. So because of this, we call it as based, and because of SI, we call it as indexed. Now BX plus SI will be the offset. Bx plus Si will be the offset. So from that, we are going to find effective address. And from effective address, the data is moved to Ax. This is based indexed addressing mode. Now coming to relative based indexed. So this is a combination of relative based and indexed. So this is the advanced to the earlier one, based index. So we are added some displacement of 50. Now 50 plus Bx plus Si will be the offset, and you are going to calculate effective address based on this offset address. That data that contains the data that moves to the Ax. So in this way, we are having 8 addressing modes, which are sequential control flow, wherein which default segments are the TS or ES. Now we'll go back to the next type of instruction calling it as control transfer. If you call control transfer, that the instruction may be within the segment or out of the segment. So accordingly, we can have two types. That is intra-segment, inter-segment. Intra means within the segment. Inter means out of the segment. And again, in each type, whether the address will be given in direct manner or in indirect manner. So accordingly, you will be having 4 types of addressing mode in control transfer instruction: intersegment direct, intersegment indirect. Similarly, intra-segment direct and intra-segment indirect. Now we'll see intersegment direct. Intersegment direct means upon executing this instruction, the uh, the CPU moves to an location which is in a different segment than the earlier segment. Then if we move to the next segment, that segment address is to be known, as well its offset address is also be to know. So that can be given in the instruction itself. Then that addressing mode, we call it as intersegment direct. If you observe the instruction jump 5000 H, 2000 H, the meaning of this one is jump to a location with a segment address of 5000 and offset address of 2000. So in this way, you are going to move to the another segment with the segment address 5000 and offset address of 2000. This we call it as intersegment direct. This 5000H is going to be the CS and 2000H is going to be the IP. So for all these 4 addressing modes, the default segment is going to be the CS. Now coming to the intersegment indirect. So in intersegment indirect, instead of giving directly the CS and IP values within the instruction, we give indirectly. That is a jump within brackets 2000H means go to an address calling it as 2000H. This is an effective address. So go to that. So this is an offset address, go to that address, and there you are going to observe the CS and IP values. So based on those CS and IP values, the next instruction is going to be fetched. The next instruction is going to be fetched. So this is going to be the inter-segment indirect. So now coming to the intra-segment. Intra-segments within the segment. When it is within the segment, segment address is same. Only one thing we need to give is the offset address. So only the offset address is needed. So in intra-segment direct, if you observe here, jump short label. So that label will give you a displacement from the current instruction to how much displacement you have to move to access the next instruction. That displacement may be either short or it may be the long. If it is short, nothing but it is of 8 bits. And if it is long, it is of 16 bits. So 8-bit displacement or 16-bit displacement, within the displacement, it can move within the segment. This is the intra-segment direct. Similarly, intra-segment indirect. Instead of giving directly the label, we are going to give the BX. Okay, so the effective address will be available in BX. So based on that, you need to jump within the segment. So this is going to be the intra-segment indirect mode. So these are all addressing modes of 8086. Thank you.